Hey guys, here's the review for Spiral 19. We're going to go through a couple problems in each section to see if we're on track. First up, we got solving some equations with logs. I'm going to try to get the exponential part by itself, which means I'm going to add 5 to both sides. That's going to make this 42, and then divide by 4. So we get 9 to the 5 minus 3n is equal to 42 over 4, or 21 over 2. Next up, I'm going to convert this to log. So log base 9, 21 over 2 is equal to 5 minus 3n. Finally, I'm going to get the n by itself. I'm going to subtract 5 to both sides and then divide by negative 3. So we get negative log base 9, 21 over 2 minus 5, all over 3. Anything that's equivalent to that would be fine as an answer. For number 3, now I've got to get the log part by itself, so I'm going to add 6 to both sides. We get log base 4 of p minus 4 is equal to 2. 4 squared is equal to p minus 4 when I convert that to exponential. And then I get p is equal to 20. For number 5, we've got a log on both sides. That means that the insides have to be equal if those are the only two things in the problem. So negative 3b minus 5 is equal to negative b plus 3. I'm going to add 3b to both sides. 2b minus 3 to both sides, negative 8. b is equal to negative 4. For number 7, we've got to combine the logs on the left using properties of logs. If I'm adding, I'm going to be multiplying the stuff on the inside, so that's log base 3. 2x squared times positive 6 is going to be 12x squared is equal to 3. I'm going to convert this to exponential, so 3 to the third is equal to 12x squared. Divide both sides by 12, and we get 27 over 12 is equal to x squared. That can reduce a little bit. That can end up being 3 over 4 is equal to x squared, and that's going to be plus or minus the square root of 3 over 4, or plus or minus the square root of 3 over 2. If I plug this back in, both of those in the x squared part become positive, so it's okay to have both answers in this case. Next up, we got some log graphing. Most of you are converting things to exponential and then working from there, and that's totally fine. So we'd end up with y plus 3 is equal to log base 1/3 of x minus 1. And we can convert that to exponential. I'm also going to switch this to y equals x. Although you don't have to, and this might be a little bit interesting if we do something different, but I'm not going to, because I don't want to screw us up on the last day of a spiral. So we get 1/3 to the x plus 3 is equal to y minus 1. So we get 1/3 to the x plus 3 plus 1 is equal to y. I'm going to plug in some numbers for x. I'm also going to identify my asymptote is y equals 1. And the numbers I'm going to plug in are going to make the exponent negative 1, 0, and 1. Okay, to make this exponent negative 1, we've got to have negative 4. To make it 0, we've got to have negative 3. And to make it 1, we've got to have negative 2. When I plug those in, we get 1/3 to the negative 1, which is 3, plus 1 is 4. So negative 4 is our first exponential point. 1/3 to the 0 is 1, plus 1 is 2. And 1/3 to the 1 is going to be 1/3, plus 1 is going to be 1.3 repeating. Okay, I'm going to convert this to my log table by switching my x and y's. My asymptote is x equals 1. We get 4, negative 4. We get 2, negative 3. And we get 1.3 repeating, negative 2. So that's going to be looking at that. We're going to have 2, negative 3, and we're going to have 4, negative 4. An asymptote at 1, and this graph is going to be an upside down log graph that looks something like this. Looking at number 11. If you want to try a different method, this is the one I'm going to do that on. So we're looking at log base 5 of x minus 1 minus 4. Just like before, I'm going to convert this to exponential. So we get y plus 4 is equal to log base 5 of x minus 1. We get 4 to the y plus 4 is equal to x minus 1. 4 to the y plus 4 is plus 1 is equal to x. And instead of an xy table, I'm going to make a yx table. I left my y and my exponent this time. I didn't actually get the inverse. And I'm going to try to make y plus 4 equal to negative 1, 0, and 1. So this is the same exact setup we're doing. We're just not having to convert afterwards. I'd also like us to notice that we got an asymptote at 1. That's going to be an asymptote at 1 for my log as well. So I'm going to put that in there. And if I want y plus 4 to be negative 1, that's going to be negative 5. And we get 1/4 plus 1 is 1.25. Okay, if I want this to be 0, that's going to be negative 4. So that's going to be 1 plus 1 is 2. And if I want this to be 1, that's going to be negative 3. And we get 4 plus 1 is 5. When I add those points in, so that's an x value of 1.25 and a y of negative 5, so it's something like this. An x value of 2, a y of negative 4, an x value of 5, and a y of negative 3. It looks something like this. That's kind of a shortcut. It's a little bit more confusing because we're using a yx table instead of an xy table. But it can save us a little bit of time in that process. Next up, we got some matrix operations. I'm going to do a selection of these just to kind of see where we are. First one I might do is number 13. We got to do some subtraction and multiply by 5. I'll do the kind of both in one step. So we're looking at 5 times negative 6z minus 6xy. That'd be negative 30z minus 30xy. Next row down would be 20 minus 25y. And my last row would be 15x squared minus negative 6x or plus 30x. And that would be a 3 by 1 matrix with 3 rows, each having 2 pieces. All right, I'm going to do number 18 next. We're looking at negative 4u times 0 as my first matrix, and that's a 1 by 2. And my next matrix is going to be a 2 by 2. When I do this, I want to double check if I multiply a row by a column, I have the right number of elements. So then if I do row 1, column 1, negative 4u times negative v is positive 4uv. 0 times negative vu is 0, so that's just 4uv. Row 1, column 2. Negative 4u times 2u is going to be negative 8u squared. And 0 times 5v is going to be 0. I don't have a row 2, so actually this is done as my final answer. So it's a 1 by 2 matrix with 4uv as my first item and our first element, and negative 8u squared is my second. Similarly, if I do number 20, I can check this is a 3 by 1 and this is a 1 by 2. Those match up because I have 1 row, 1 column. So then if I do row 1, column 1, that's 1 times negative 3 is going to be negative 3. Row 1, column 2 is going to be 6v. Row 2, column 1 is going to be 12u. row 2, column 2 is going to be negative 24 UV. And then I've got 2 times negative 3 is negative 6. 2 times 6V is 12V. Interestingly, this made a 3 by 2 matrix out of a 3 by 1 and a 1 by 2. For number 21, I've got to try to get C by itself. I'm going to add the other matrix to both sides. We get negative 3C is equal to negative 12 and 18. If I multiply both sides by negative 1/3, we end up with C is equal to 4, negative 6. And I'm done. Finally, we've got some determinants and inverses. For 23, I'm going to do the determinant. 2 times negative 4 is going to be negative 8. I'm going to take that and subtract negative 12, which gives me positive 4 as an answer. For 25, I'm going to rewrite the first 2 columns just to make my life a little bit easier. And what that's going to do is make it so I don't have to loop around when I do my rows. So we got negative 1 times 2 times 3, that's negative 6. Negative 1 times 2 times 0 is going to be 0. And negative 1 times 5 is going to be minus 25. Going backwards, same thing, we're going to use those 2 extra rows to not have to loop around. 3 times 5 times negative 1 is negative 15. And then we've got negative 1 times 2 times 5 is minus negative 10. And then we're going to have negative 1 times 2 times 0, so that's minus 0. So we've got negative 6 minus 25 is negative 31, plus 15 plus 10 is going to be negative 6 as my final answer. For 27, we've got to find the inverse. We're looking at flipping my A and D. We are looking at making my B and C negative. So that's going to be 4, 6, and 3, 5. And then I'm going to multiply by 1 over the determinant. So 24 minus 15 is going to be 9. That is the inverse of that matrix. For 31, I'm going to write this as a system. So that's going to be negative 1, negative 10, negative 1, negative 1. XY is equal to 37, 1. Okay, I know I have to multiply both sides by the inverse. 1 minus 10 is going to be negative 1/9. Out front, I'm going to flip my A and D, but they stay the same. And it's going to become positive 10, positive 1. The nice thing is that the stuff on the left is going to cancel out. So I'm just writing that as kind of a formality to show that that's what's there. And the stuff on the right, when I multiply by negative 1/9. And then negative 1, 10, 1, negative 1, 37, 1. Hopefully this cancels out rather nicely. So we get negative 1 times 37, okay. That's going to be negative 37, plus 10 is going to be negative 27. And oh look, that comes nicely into that. We're going to have 1 times 37 plus negative 1 times 1 is 36. And those numbers come out nice too. That ends up giving us xy is equal to positive 3, negative 4 as a 2 by 1 matrix.